A bird in air looks at a fish vertically below it and inside water. H1 is the height of the bird above the surface of water, and H2 the depth of the fish below the surface of water. So the scenario is like this. Suppose this is the surface of water and it is air, and here it is water inside. So suppose fish is somewhere here. So it is given that H1 is the height of the bird. Bird is here. It is air, and here it is water. Okay, so bird is here. H1 is the height of the bird above the surface of the water, and H2 the depth of the fish below the surface of the water. Okay, if refractive index of water with respect to air is mu, then the distance of the fish as observed by the bird is. So here the thing is that whenever the observer and the object lie in different mediums, in that case the depth of the different medium will appear different. And how to tackle that? There is a very simple way to do that. What happens, suppose observer is there in some medium mu1, suppose. I am telling you this for such similar problem so that you can tackle any type of such problem. So suppose that mu1 is the observer's medium and mu2 is the medium of some other material medium. Here it is, suppose T is the thickness and mu2 is the refractive index. So observer is there in medium mu1 and observe this, then the thickness of this medium to this observer will appear as T divided by mu. But here what is mu? Mu is refractive index of object's medium with respect to observer's medium. Okay, with respect to observer's mediums. So mu is this. So that is something that you have to remember. Okay, in this question, as you can see that bird is here. So from here to here, there is no change in the distance because this is air and bird is in air. So H1 will be the same. And as far as H2 is concerned, to the bird, this H2 will appear as H2 divided by mu. And what is that mu? Mu is the refractive index of object's medium, means water, with respect to the observer's medium, in which is air in this case. So mu is given as the with respect to air, so you can use it directly. So mu. So H1 plus H2 upon mu will be the answer to this question. So of course the B will be the right answer. But suppose if I ask you in this the same question that what will be the distance of the bird as observed by the fish, then what would be your answer to this question? If I say that what would be in this question, it is asked that distance of the fish as observed by the bird. I am asking what is the distance of the bird as observed by the fish. In that case, what will happen? Suppose if fish is observer, in that case this depth H2 will remain as it is. There won't be any change, and H1 will appear as H1 upon mu. And what is that mu? Mu is refractive index of object's medium with respect to the observer's medium. This time object is in air and observer is in water, and mu is something with respect to air, means water with respect to air. So air with respect to water has to be 1 upon mu. Alright, so you have to remember this. What is this mu? Mu is refractive index of the object's medium with respect to the observer's medium. And how to find that? Just divide the object's medium refractive index by the observer's medium refractive index. That means mu2 upon mu1. That is how you get. And here mu2 upon mu1 is given to you. And here you have to use mu1 upon mu2. That is why I have used 1 upon mu. So answer to my question will be H2 plus mu H1. So C would have been the correct answer to this question if it was asked that way. But in this case, we are asked the distance of the fish as observed by the bird. So option B will be the correct choice.